Right, and in my previous video, I talked about how to use the unit circle and using our reference angles to evaluate functions, and we did the examples in degrees. So now let's do the example in radians. So we're going to evaluate cosecant of 17 pi over 6. So one way to do this is, number one, we can leave it in radians or we can convert it to degrees. Now, because we already filled out our unit circle here, we do know the reference angles in radians already. There is a really nice thing about radians is when you have it, it really does kind of help you out. And let me show you what is nice about keeping it in radians. We have cosecant of 17 pi over 6. So first we want to find our reference angle. So number one is, let's take a look at, is this going to be greater than 2 pi or not? So number one, a full circle is 2 pi. So 6 goes into 17. That is more than 2. So what we're going to do is we're going to subtract 2 pi from it, right? 6 goes into 17, 2, and 5 over 6 times, right? So we know that it is larger than 2 pi. So we're going to subtract 2 pi. We have to get a common denominator, so we're going to multiply by 6 over 6. So therefore, this is going to be 17 pi over 6 minus 12 pi over 6. So that is going to be 5 pi over 6. So that is our reference angle, 5 pi over 6. Now, 5 pi over 6, looking at that, that is less than a pi, right? Less than a pi, because 1 pi would be 6 pi over 6. So that tells me that 5 pi over 6 is here. Now, how far is 5 pi over 6 to pi? It is only pi over 6 away, right? If I add another 1 pi over 6, that would make it 6 pi over 6, or pi. So notice the reference angle is pi over 6. It's the same denominator. So now that we know, we're looking at cosecant of pi over 6. Now cosecant, we have to remember our reciprocals. Cosecant is related to sine. So this is really 1 over sine of pi over 6. So what is sine of pi over 6? So pi over 6 is 30 degrees, right? Pi over 6 is 30. So here, sine, the y value is a half. So therefore, this is 1 divided by a half. And so let's change that. It says 1 divided by a half. You're dividing by a fraction, so flip. So the answer is 2. Now we look at what sign is it though? A, S, T, C. Now it's in the second quadrant, so therefore our sign values, our y values are positive. So therefore this answer is positive. Now another way to do this same problem in radians is to go ahead and convert it to degrees. So if you find the degrees is easier for you, then certainly you can convert it to degrees. And then you only have to convert it once, because once you find what that reference angle is, you just look at the chart to find out what number you need. So let's go ahead and do that. Let's convert this. So we're looking at cosecant of 17 pi over 6. So I'm going to do this in degrees. I'm converting it to degrees. And so what I'm going to do is let's multiply by 180 degrees over pi. So 6 goes in 180, we know 30 times. So we're looking at 17 times 30 degrees. And so this is going to be 510 degrees. So we're looking at 510 degrees. And so we know that that is greater than 360 degrees. So let's go ahead and subtract. So we can figure out where it ends. So this is 0, and let's do this. So 5, this is 150 degrees. So let's figure out where 150 degrees is. Here. 150 degrees is here. So we notice that 510 plus another 100, well, it's 360 plus 150. So the angle is here. That's 510 degrees, or we said already that it's 150 degrees. Then how far is it now to the x-axis? So that is 30 degrees. So notice it's still the same. We're looking at cosecant of 30 degrees, which is the same thing as cosecant of pi over 6, right? But maybe this is what you find easier, so please go ahead and convert it to degrees and then use the table in order to evaluate. So try out example number 11. It's very similar to letter B with the cosecant. Remember, what is secant related to? And then see if you can convert it to degrees, and then find your reference angle, and then the value of 11 pi over 4 for this is going to be cosine. So let's work through this together. 11 pi over 4. So let's go ahead and convert it to degrees. So 180 degrees divided by pi. So 4 goes into 180 degrees 45 times. So now we're looking at 45 degrees times 11. So we're looking at 495 degrees. Again, it's greater than 360, so let's subtract. So this is going to be 135 degrees. So we're looking at secant, number 1, it's 495 degrees. So that's what we found when we changed it. Then we found the coterminal angle of 135 degrees. So it's lots of good vocabulary. Next, we need to find the reference angle. Okay, so 495 degrees is really 135 degrees, which was here. Remember, this is 90 and 180 degrees. And so if we were to draw this, it's one full circle plus more. And so if this is 135 degrees here as our coterminal angle, we want to find the reference angle. So how far is this to the x-axis? 180 minus 35 degrees, that is 45 degrees. So whenever you are trying to find these, it will always be one of these angles. The reference angle will always be 30, 45, or 60 degrees, unless it's a quadrantal angle, which would be at 0 or 90 or 360. So just another little check for yourself if you don't get something that is a perfect number that you can't use a table for. There's no tricks. It will work out. So we're looking at 45 degrees is our theta prime. So we're looking at, let me do the work down here, secant of 45 degrees. So what's really cool about 45 degrees is that whether it's sine or cosine, it is root 2 over 2, right? 45 degrees, they're the same value, so that's really nice. So secant of 45, number 1, is 1 over cosine of 45 degrees. Then cosine of 45 degrees is root 2 over 2. So now let's simplify. So this is 1 divided by root 2 over 2. Then we'd have to flip and multiply. So we're looking at 2 square root of 2. Then we need to rationalize the denominator. So this is 2 root 2 over square root of 4. Square root of 4 is 2. And so the final answer is root 2. Now, we have to know what angle are we in. We're looking at cosine, and it is in quadrant 2. So the sine ultimately is negative square root of 2. So after all of this, the answer to this problem, secant of 11 pi over 4, is negative square root of 2. So again, just to kind of go over how do you evaluate functions with these, is number 1, given an angle, you may or may not have to find the coterminal angle. So if it's greater than 360, greater than 2 pi, you need to find the reference angle, the coterminal angle, like we did here. We found 135. Then after that, you need to find the reference angle. How far is it to the x-axis? And it's always positive. So here, you find that. Then, once you find the reference angle, you look at that trig ratio they give you, a trig function, cosine, tangent, cosecant, secant, sine, cotangent. You use the, whatever function that is. Cosine is x, sine is y, tangent is y over x. Then, like in this example here, if we're looking at cosine of 30 degrees, look at the chart. What is cosine at 30 degrees? Cosine of 30 degrees is root 3 over 2. Once you determine that number, then you look at, so it's really important to have the drawing, what is the sign in that quadrant? So ASTC, all of it's positive in quadrant 1. S is sine. Sine is positive in quadrant 2. T, only tangent is positive, and C, only cosine is positive in that quadrant there. Okay, so you get some more practice this week on these problems. I know this is a pretty heavy topic, and so practice will be very nice to do.